Okay, so let's begin. So vector subtraction, I can explain it in one sentence. You know how yesterday you add the x and y components? In vector subtraction, you subtract the vector components. There you go, I'm done. That is literally it. I'll show you an example, of course, but you know, if I had to show you that in 30 seconds, that's what I would say. You simply subtract the components. The real hard problem, and I think Renee, you'll agree with this, the real hard problem with vector subtraction is knowing when to subtract. No? Or is it knowing when to subtract or how to subtract? Okay. Well, let's see if we can fix it today. Okay. We know, you should remember from grade 11, that if you're talking about planes, and this might be new to you, so you pay extra close attention. We know that the resultant is equal to the plane plus the wind, and these are all vectors. Right? If you're flying a plane, the resultant, yeah, put it away. Okay? Okay. Shelby, take it away and put it over there for her, would you? Do her a favor. No, put it over there. It's actually not. We know that the resultant is equal to the plane vector plus the wind vector. And if you were to add them, you would place them in a tip-to-tail fashion, right? The result is from where you start to where you end, right? And the plus sign here, the plus sign right here indicates tip-to-tail. Okay, so when we add vectors, Renee, we place them? Tip-to-tail. Excellent. Okay, so if you were to rearrange r equals p plus w, if we solve for p or w, right? If we take this and we move the w over to solve for p, or if we take the p over to solve for w, we end up with, what is it? Subtraction. Right? When we solve for the plane speed, or when we solve for the w, we end up with subtraction. So that's how you know to do subtraction. I repeat, that's how you know to do subtraction, because you're solving for the plane or solving for the wind. This will mean vector subtraction when trying to find the wind or the plane speed. I'm not sure why I put W or plane speed. It should be either. Let's change it. Raiden, listening part of the day. So, to subtract vectors by components, what do? Key thing of the day. To subtract vectors by components, simply subtract rather than add. Why did I cover that up? Because I see you writing ahead, just blindly copying. I could be writing in French right up here, and you guys just be writing down letter by letter. I don't know what it means, but I'm going to copy it down. Don't do that. So, here's the example. Now, I'm going to give you a simple one where I tell you that it's subtraction. Here's a simple one where I tell you it's subtraction. I'm gauging what Joel's doing back there. Here we have C equals A minus B, just completely made up, just to show you the steps of vector subtraction. And I'm just going to make up numbers. A is equal to 12, east 26 south, and B is equal to 8, east 14 north. Is this a good thing to write down? Yeah, because it's an example. This you can look back and try to, do something with, right? Okay, anyways. Okay, so here are my vectors, right? So 12 whatevers. I didn't even put units on it because that's how unimportant it is, right? Kilometers, meters, who cares? It's 12 at east, 26 south. Maybe some of you need help with this. East, 26 south means look east and go south. How far south? 26. East, 14 north. East, 14 north, right? Okay, so I have that on the next page here. So east, or 12 east, 26 south. Let me get my cover up thing. Okay, so here's vector A, right? It's 12 whatevers at east 26 south, so east 26 south. So this is AX, and this is a good review from yesterday, Blair. So I mean, if this works for you, then you don't even need yesterday, right? AX is on the side, AY is up and down. Is the X always left to right?
Why is it 12 the hypotenuse?
12 is the hypotenuse, because that's like how long the vector is. The vector is 12 meters, kilometers, whatever, long, right? At east 26 south. Is the X always left to right?
Yes.
Yeah, that's what X means. Is the Y always up and down?
Yes.
Is the Y negative here, Braden?
Certainly is.
Yeah, it is. It's going down.
It's going down, yeah. What about the X?
No, it's positive.
Positive to the right, well done. Okay, so AX is 12 cos 26. Is the X always the cos? Will? Not always. The X is not always the cos. How do I know it's the cos? Because it's adjacent. The X is adjacent, so it's cos. If the one is the cos, if one is cos, is the other one sine? Yes. Okay, so 12 cos 26. Well, it's actually sine, S-I-N-E, and cosine, but those are abbreviated to sin and cos. But we usually just say sine. There might be some people that call it sin, I don't know. Joel.
You always say it in French, Jackson.
Yeah.
I don't understand how you figure out if it's close.
Okay.
Wherever the equal is.
So here's the angle. Here's the angle, right? Cosine is adjacent over hypotenuse. And sine is opposite over hypotenuse. And that's just definition, Joel. Okay, that like comes from the sky. Oh, okay, fair enough. Okay. We did, yeah. Okay, so anyways, 12 cos 26, 12 sine 26. So punch it in. Remember, you got to be in degrees. 12 times cos 26. I get 10.8. Positive, because it's to the right.
Excuse the interruption. Could all grades 10 and teachers teaching a grade 10 class please bring them down to the multi-purpose room for a presentation? Thank you.
I get minus 5.3. Yeah?
But you have to know you add that negative when it's going down.
Yeah. It's not going to come out of your calculator. You have to add it in because it's down. Exactly. Good point. Okay, here's the B's. Right? B is how long were they? So the hypotenuse is 8. X is here. Y is there. Again, the X is adjacent, so it's going to be cosine. So Bx is 8 cos 14 and By is 8 sine 14. Go ahead.
So we were learning yesterday.
Nothing. Has anything changed from yesterday?
We were finding x and y and we were finding the r.
When we added them together, we found the R. We haven't got to that step yet.
I know, but so
Just hold on. Hold on. I will compare to yesterday at the end, okay? 8 times cos 14. 7.8. 8 times sine 14. 1.9. Both positive because it's right and up. Right? Okay.
if it goes left, it's
Left is negative, yeah.
left and
Down is negative. Yeah.
Okay. Just start that somehow.
Okay, now, because we're doing vector subtraction, we're trying to find vector C. So Cx is simply going to be Ax minus Bx, and Cy is going to be AY minus, oh, I appear to have made a typo. What should it be? This should be? Yes. I'm glad to see that you see that. Means you're following along. You're not just blindly copying letters. Was that? Not a shot. No. What's the what? Oh. It's not the right font, I think. I don't know what's going on there. Okay, so what do I do? So this CX is going to be what? Oops. The AX, 10.8. Why subtract? Vector subtraction. AY minus 5.3. Subtract 1.9. That's 3.0. Yeah, it's basically that, you're right. And that one's going to be negative, right? 3.0, right? 10.8 minus 7.8. Let me see what I got on the next page. No, I have nothing. Should I keep going on this page or should I go to the next page? Probably go to the next one. Let me just see what I got ahead here. I got nothing. I didn't finish this. No, is that it? Is it? What have I found? I've just found the x and y components of C, so I now have to... What do you mean, where's the y?
Your 14 is on the BX, and then your 8 is on the...
Uh-huh.
Or maybe it's that's what it just says there. Okay, never, keep going.
Okay. So now what's the next step? You got to put the C back together again, right? So CX is equal to 3 and minus 7.2. So CX, right? And CX was 3.0, and the CY was minus 7.2. Where do those numbers come from? Just found them out right here. Okay, what am I going to call the hypotenuse here? Just C, really, right? I mean, in this case, it would be C, right? It might be R in some cases, Dan, or when you do vector subtraction, it's like when you do regular math, you call it the difference, right? But in I don't think there's a word for answer to a subtraction question in vector language. So I usually just call it. It depends on the situation. Yeah. Quite often it's plane or wind or boat or current. But I'm calling it C here because that's how I set it up at the start. There was another question over here, but I think someone figured it out. Why it's negative? Okay, so now what's the next step? C squared is 3.0 squared plus minus 7.2 squared. And don't forget to take the square root. I get 2.8. That can't be right. 7 point what? Yeah, I think I double square rooted it somehow.
Yeah, 7.8.
Now we don't have a unit though, right? Because we didn't introduce any units to begin with. So it's just 7.8 whatevers. Right? And of course you need the angle. Tan opposite over adjacent, right? Opposite over adjacent. Do I need the 7.2 in my tan thing? No, because it's just a triangle. 7.2 over 3.0. No.
I think I go like that.
Why is the triangle like that? No, I'm not sure what you mean by it though. Like, why is it to the right and to down?
Oh,
I'm having problems here with this calculator. It's too dark. This is the one that Megan wrote. What's the answer? 67.38? So 67, right? Okay, so that's going to be, I'm almost done here, hang on. So if it's 67.8, we're going to say that's 68, but it's to the right, so it's going to be? Oh, so 67 then. Okay. 67, I just misheard. So it's to the right, so it's going to be east, 67. Let's compare this to the steps from yesterday. Exactly. What did we do? Found the x and y components for the first vector. Found the x and y components for the second vector. The only thing that's different is instead of adding them, we subtract them. And then put them back together. Vector subtraction is the same as vector addition, except you subtract. Which is what I said when we first started. Right?
Question, like, I don't know, it's like 7.8 kilometers, whatever it was in the back.
Yep.
Do you have to put that together at the end, or can you?
Yeah, it's good enough like that. I mean, some teachers might make you write in a sentence or whatever, but... Okay? Okay. So, I gave you 3 here. Answers are at the bottom, and because I just happen to do solutions on the back side, well, I might as well copy that for them as well. So, you have the solutions to the first 2 on the back, the third one was on the next page. I didn't bother copying it. Okay? So, you got the rest of this period to work on this vector stuff. I'll be handing I know how to do it all. Let me finish. I'll be handing the pretest out tomorrow. Unless you're not here tomorrow, then I'll give it to you today. But I'm not handing it today because you're all, I'm going to do this. Can I get some help?
Okay,
Coming.
You don't have to. I didn't get one of those pages.